Our next presentation is by Jinru Shia, who's the director of GI pathology, and as I said earlier, been working on heterogeneity in liver cancer. And so she's going to talk to us about genotype-phenotype correlations in carcinomas with hepatocellular differentiation. So sort of looking at the other end of the spectrum of primary liver cancer. Thanks, Jin.
Thanks very much. I'm a little nervous, but let's talk about it. So as David mentioned, in Dr. Farrell's honor, we're focusing on liver tumors. So now we thank Kali for that beautiful talk. Now we're going to turn our attention to cancers with the hepatocellular differentiation, as David mentioned. And here we know the vast majority of liver cancers with the hepatocellular differentiation is really simply HCC, right? And then we have this little sleeve of a combined hepatocellular cholangiocarcinoma. So the plan here is we're going to start by a very quick overview and really just to have another look at how bad these tumors are. Kali mentioned the intrahepatic cholangiocarcinomas are very bad, and liver cancers, hepatocellular cancers are just as bad. And then for the second part, as we planned, we're going to talk about one of our ongoing research efforts, where we looked at this heterogeneity issue, both histologically and molecularly. And this really is an effort that is still very much ongoing, and the stuff we're going to review now is more that from a sort of interval analysis. But we're excited, and let's talk about it. Okay, so how bad is HCC? HCC is truly a major health threat, as we would agree, and on multiple fronts. And first of all, just like for intrahepatic cholangiomas, for HCC, we don't really have good treatment, and that obviously is one of the main reasons why there's such high fatality rate in these tumors overall. Even in the US, the 5-year survivor is lower than 20%. And worse yet, the incidence is still on the rise, again, similar to cholangiomas. And this is certainly true for the US, and the incidence for cholangio is increasing, and so is the incidence for HCC. This is to show that over this 10-year period, there had been a 50% increase in the incidence of HCC in the US. So we know HCC is a very complex disease, and some 80 to 90% of these tumors are associated with an underlying chronic liver disease and some degree of cirrhosis. Of all of these underlying conditions, we know fatty liver disease is a particular threat, and especially non-alcoholic fatty liver disease, and especially in developed countries, US included, of course. And I know Dr. Farrell, our guest of honor, will be talking more on this very important topic, so we look forward to that. We mentioned we have no good treatment for these tumors, and to achieve any kind of success or hope is really on finding these tumors early. But even then, our treatment options, surgery, ablation, are associated with very high recurrence rate. Transplantation can lower the recurrence rate, but we know transplantation has its own set of problems, right, difficulties. Now, once the disease passed early stage, then pretty much everything becomes palliative. Now, what I wanted to point out here is that for all these treatments, there are no predictive biomarkers. For checkpoint inhibitors, currently approved as second-line treatment in advanced HCCs, MSI, a marker we use for other organs, a marker we all love, right? I love. But it's essentially irrelevant here. And just like in cholangiomas, MSI is just so rare, if it happens at all, in HCC. So I think we see that this is just a tough disease to deal with, and much of all this difficulty is really because we just don't understand this disease well. The current literature suggests that this combined cHCC, the situation here is even worse. Now let's have a look at the pathology. And here we have a tumor sitting in a cirrhotic background. Still get resected, it must mean that it is early stage and patient has no contraindications. Now at our institution, as Kali alluded to, many cases are non-cirrhotic, and having a non-cirrhotic background certainly increases the chance of surgical resection. And this here is to show that these tumors can send out cyclid nodules. And some of you may have noticed that this is, what type is this? This is a fibrolamellar HCC, but conventional HCCs can do this as well. And all of them love the portal vessels. And yet another contributory factor to just the badness of these tumors. The histology of these tumors, very colorful for one thing, but as we know best, just like cholangiomas, it can be very heterogeneous, right? So these illustrations here are for the major subtypes that are recognized by our current WHO. They include trabecular, solid, pseudoglandular, pseudoacinar, and macrotrabecular. Beyond this, there is also a slew of other patterns that can happen in HCC as well, as we see here. Our current WHO requires more than 50% of the tumor having these particular patterns for the tumor to be classified as a particular subtype. So if you require more than 50% of the tumor to have these features, then the incidence of each of these subtypes becomes very low, single digit. A much more common scenario, I hope you agree with me, is that you tend to see a little bit, much less than 50% of a lot of patterns within the same tumor, right? So here's a tumor that's relatively small, already have all these different patterns, and there's even a fifth pattern here that, that's not illustrated there, and that's more fibrotic or scirrhous. So the histology of HCC is very heterogeneous, and histology heterogeneity is present in cHCC by definition. And we already heard from Kali, our WHO requires distinct morphological patterns, one fitting for cholangial, one fitting for HCC, for the tumors to be classified as cHCC. So by definition, you have at least two different components, and you add that to the additional variations within each component, the picture can be very busy. So with all these heterogeneous, complex morphological patterns, an obvious question that follows is, what does it mean, right? Does it, and to what extent does it contribute to the badness of these tumors? These days, as we know, that we're getting deeper and deeper into the molecular genomic aspect of things. And Kali was just saying genomic typing is very important. So in that context, the next question is there a parallel heterogeneity at the molecular genomic level? Maybe all this histology craziness is simply a reflection of a marked molecular heterogeneity, and maybe it is that molecular heterogeneity, or where in the genome that heterogeneity is, that is holding the key, or one of the keys in our understanding of these tough tumors. So you see, that kind of thinking is essentially what drove us to the study that we're going to talk about now, a study that looked at this heterogeneity issue, both histologically and molecularly. And for the molecular part, we particularly focused on the genomic copy number alterations. So knowing how heterogeneous these tumors are, heterogeneity does seem like a great angle to tackle these tumors from, right? Now, I wish I could claim credit for the idea of the study, but that credit really belongs to these people. David at the helm, who started this whole thing, along with Dr. the Lau Lab, and Shauna, who is a postdoc from the lab, a huge part of this effort, and Timur, another huge part. So this is the team that sort of conceived this project and then built really a solid foundation background to support this study. So there are multiple parts to this foundation or the background for this study that supported the effort. The important parts are, first, the literature background. And from the literature, as Shauna puts it, a lot has been done, and yet little is understood. Yes, there have been a lot of molecular genomic studies of these hepatic tumors, and yes, they improved our understanding somewhat, but not nearly enough. Here's what the TCGA put out in 2017 for HCC, a complex analysis of some 300 plus HCCs and utilizing all these various different platforms that the TCGA is really good at utilizing. And down here is essentially what the data boiled down to. And just to highlight a couple of major findings here, I have on this slide some summaries. And first, they identified the significantly mutated genes, like all TCGA papers that provided the mutational profile of the different tumor types. So for HCC, and included in the commonly mutated genes are CTNB1 gene encoding beta-actinin, TP53, no surprise, and TERT. TERT promoter mutation turned up as the most common mutation, a phenomenon actually that had already been observed by others. And then there's another major finding from this TCGA study is something related to our study, and that is about the structural or copy number alterations. So the TCGA made a mention of arm-level alterations involving chromosomes 1, 8, and 17, but they particularly pointed out the importance of or the presence of focal changes, amplifications, and deletions involving a long list of genes, and they particularly pointed out some important ones that are affected. What I wanted to point out here is that this kind of data from TCGA, as well as data from other studies, they all seem to indicate that copy number changes are important events in HCC. But the efforts so far have been more about the genes, sort of gene-centric, and not so much on the global structural changes of the genome. And what about our MSK impact? Well, as of just a couple of days ago, MSK has impacted this many HCCs and a handful of cHCCs. And from this oncoprint here, right away, we can see our impact indeed detected the most common mutation, and that is the TERT promoter mutation that's represented by these teal-colored bars up here. And for mutational profiles, just to complete here, I have this little summary table. So that's HCC, and for cholangios, we heard from colleague, IDH mutations are the most common. And no surprise, the mutational profile of this handful of cHCCs sort of sit right in the middle. But what I really want to do is bring you back here to this oncoprint and look at these red bars and blue bars. These are for copy number changes, copy number alterations, amplifications, and deletions. And I think what our impact data are showing is, again, that this kind of CNAs, copy number alterations, are indeed recurrent events in HCC. But again, just like TCGA and many other studies, their efforts so far have been more on genes, so gene-centric, not the global pattern, number one. And number two is that almost all the studies, most of the studies are treating all HCCs as one tumor and all cHCCs as one tumor, right? Not much attention is paid to the tumor heterogeneity. Well, I should mention that for cHCC, there have been a couple of studies that did look at the C and HCC components of cHCC separately. And here I have one such study here to just as an example. So this one is an whole exome sequencing study on cHCC, made it to a big journal. And again, you'll notice that this is more exome-centric. And so the essence of this study is that by utilizing whole exome sequencing, they identified a whole bunch of private events, mutations, copy number changes, as well as shared events between the two components of cHCC. The shared events then allowed them to conclude that these two things are indeed clonally related. And these Venn diagrams here, 7 Venn diagrams here, sort of illustrate the findings of their study cases. And you'll notice here, the number of their study cases here is 7. So this sort of brings us back to what enabled us to do our study. Not only is there a sort of void in the literature with regard to tumor heterogeneity, number one, and this kind of global structural changes across the genome, number two, and therefore our study that aims at focusing both of those things becomes important and pertinent. But there's another supportive component here, and that is about case numbers. Here, in our department, we do have a good supply of these tumors. We also teamed up with our colleagues from Cornell, and by doing that, we get even more cases. I don't know if Meredith is in the audience, but Meredith has helped with this project a lot, and she's a pathologist from Cornell, so we thank you for that. Now, a third component of this foundation that supported our effort and particularly made it possible for us to look at the copy number alterations at such large scale is that in the Low lab here in Zuckerman, they have long had an interest in these global structural changes of the genome. I've heard Dr. Lau making comments that, this kind of global genomic changes they are a special type of mutation. They're functionally different from point mutation, and they're biologically important. So the lab has developed tools to study that. And so the particular tool that we are using for our study is this low coverage whole genome sequencing method, using that to sort of scan the genome for copy number changes. And this indeed is a tool that has been shown to be superior to the more conventional array-based methods. And Shauna Timur in the lab tell us that this provides more coverage and better resolution and so on. Shauna also wanted me to point out that comparing to another alternative methodology, which the lab also has, and that is single-cell sequencing. This method is cheaper, easier, and allows us to study a lot more samples. So you see, we got ideas, got cases and tools to study those, and with all those things in place and all the ideas in mind, we proceeded to our study. So these are the specific steps we went through. Obviously, we started by identifying cases, this is still an ongoing effort, and at this point, we have 200 patients analyzed and more than 900 samples. Most of these are HCC, but we also managed to get 50 cHCC cases, and most of them are primary tumors, but a handful, some of them, a subset also has had recurrences and metastases. So some patients had more than one tumor, and then each tumor had multiple samples, multiple regions that were identified to have specific histological patterns. So for the purpose of defining histology heterogeneity, we particularly focused on number one, nuclear grade, and number two, all of those various patterns that the WHO talked about. So we marked these distinct regions with various histologies on the H&E, and that obviously became our guide for us to punch cores of paraffin tissues from those regions. In the lab, we then isolated genomic DNA, performed low coverage sequencing, and analyzed the copy number alterations. Now, Shauna and Timo in the lab, they have this very sophisticated algorithm that takes in all the data, all the information, digests it, and spits out all the CNA data in various format. A main format is this type of plots. Now, I have a couple samples here for us, those of us who are not familiar with this kind of analysis, and just to get a sense what they tell us. I know we have molecular gurus in the audience. For the molecular gurus, I don't know, you go to sleep. So this is for us who are not familiar. So what this kind of, all these beautiful plots are provided by Shauna, and thank you, Shauna, if you're here. What this kind of plots tell us is, again, the structural changes across the whole genome. So you see top here, we have all the chromosomes, okay? And this is for an individual sample. You see a lot of action here, but if we zoom in into specific regions, then we can figure out what's going on there. So this one, for example, chromosome 4, and you can see essentially that entire chromosome is lost. It's going down there. So this is detection of loss of a whole or most of that chromosome, okay? Now this is chromosome 8, and we see two patterns here. To the left, to my left, there is this, this portion is where the short arm is, and you see a loss. And then to the right, where the long arm lives, you see it's going up. That means there's a gain. So this is detection of arm level loss gain, okay? And then we can also detect focal changes, which refers to much lower regions and down to individual genes. And in this one, we can see it's going way up. So this is a detection of a focal amplification. So this is an individual sample, and now we have a bunch of samples, a sort of a frequency plot. And again, this is showing us essentially the frequency of the changes of these specific chromosomal regions of this bunch of samples. So for chromosome 4, you see a lot of them lost, this whole chromosome. And then for chromosome 8, again, you see a lot of loss gain there. So that is just a little flavor taste of this tool that we used for our study. With this tool, the first thing we saw was something not surprising at all, but nonetheless we were very happy to see, and that is that most, if not all, CNA patterns that are reported by TCGA and many other studies are captured in our analysis and in our plots. So this here, here we're just using TCGA as an example to for comparison. So what happened here is that Shana Timur took all the raw data from TCGA and analyzed it the same way as they do with our own cases, so they're in the same format. And you notice, remember that TCGA mentioned arm level changes involving chromosomes 1, 8, and 17 as indicated here, and you see them being nicely detected in our series as well. In fact, to the seasoned eye, which I do not possess, but Shana, Timur, they can tell that our plots are actually even better. And as we mentioned before, that the method we used is actually known to be superior to most array-based methods, and SNP array was what the TCGA used. So this is no surprise. So that's good, very good to know that the method worked and is working. Now next we dove into the specific chromosomal region copy number changes of our samples. As we mentioned, we have close to 1,000 samples, and each sample has information across all these chromosomes. So I guess we can imagine that the amount of information is huge, daunting, really. And in fact, Shana, Timur in the lab are still right now very busy trying to figure out a most effective way to manage this information and to ideally present it in some, I don't know, mathematically or bioinformatically effective way, maybe some computational model. But while that model is being developed, we already have some very exciting, interesting, really encouraging observations that we will share here. So first and foremost, we noted that heterogeneity to various degrees exists at the CNN level as well. And here, to illustrate that, I have a sample case here. And so these are plots of 3 different regions from one tumor, and they're different. So to see the difference, let's start with one particular region, chromosome 8. We like chromosome 8. And you'll notice the top 2 panels, they look very different from the bottom one, right? Now, if we zoom out and focusing more on the global changes of this entire genome, then you'll notice that the top 2 genomes are much quieter, and the bottom one looks much busier, right? So Shana, Timur, and others in the lab, they use the word chaos to describe these busier-looking genomes. So this region has a more chaotic genome comparing to these 2 regions. So you see, with our eyes trained this way, focusing more on the global patterns, right away we see interesting things. We see that this kind of global chaos, or the degree of it, is showing patterns that are really suggesting or hinting towards its biological significance or importance. And more specifically, what we saw was that starting from the primary, so a chaotic genome, if detected in the primary, seems to be the one that would go on to progress to lead to progression. And then within the progressed diseases, those that happened faster, sooner, or those early recurrences and therefore more aggressive, tend to be even more chaotic. And then when you compared the intrahepatic recurrences versus distant metastases, guess what? The distant metastases is even more chaotic. Very interesting. So here are some examples. So this is the same case that we saw just now, that we already identified that this region has a more chaotic genome. And look what's happening to the metastases. So these are 2 separate metastases from this same case. And notice, number one, the metastatic tumors have very chaotic genome. And number two, that these genomes resemble this one the most, right? Here is another case with metastases. And again, notice the complexity and chaos of these metastatic genomes. And this is certainly more complex, and we see it in, again and again, more complex than intrahepatic recurrences. This is an example of intrahepatic recurrence, and this one actually happened within a short time frame. So these are early recurrences, and therefore biologically they're of the more aggressive types among recurrent cases. And you'll notice the degree of chaos here. Still chaotic, not as much as metastasis, but still chaotic, right? So these are early recurrences, therefore clinically aggressive. And now look at this one. These are more intermediate stage diseases within a recurrence-free interval in an intermediate range. This particular case recurred at 29 months. You see what's happening is the genome becomes quieter. Now look at this really late recurrences. We have a handful of such late recurrences with a recurrence-free interval of reaching 10 years and some of them even 20 years. And a consistent finding here is that they have a much quieter genome. Very interesting, right? Now, this kind of tendency of a more chaotic genome associated with a more aggressive behavior is indeed observed in our cHCC cases as well. So this is cHCC. First of all, you'll notice that there are differences and similarities between the cholangial and the HCC part, just as others have reported. And then you'll notice the complexity of the genomes here. This is an example of those that recurred sort of in a short time interval, and therefore more aggressive early recurrences. This is also another early recurrence case. This one recurred at 4 months. The genome is still chaotic. Now look at this late recurrences. This particular one had a recurrence-free interval of almost 10 years. And you'll notice that the genome becomes quieter, especially on this part of the genome. Now, our cHCC cases do indeed exhibit certain unique features when you compare the pure HCCs. And one of the features is illustrated here, and that's all these things that's happening down here, especially involving chromosome 18. And that seems to be more, that's only present in the cholangial part and not in the HCC part. Right now, we're still busy trying to better define the nature of these alterations. And one of the things that we are also doing that we think might shed some light is impact. So we are impacting all these cHCC cases, and hopefully that will allow us to characterize these things better. But overall, we thought the observations are very positive and encouraging. And we will need a lot more characterization, validation before we can be more definitive. But as is, the findings are hopeful. Now next, similarly, when we zoom in on to specific chromosomal regions, the findings also appear very hopeful. We mentioned that the TCGA and others have pointed out that arm level changes on chromosomes 1 and 8 are particularly more characteristic in HCC. One feature that has not been emphasized much in the literature, but it was observed by our team, is about the dosage of those changes. And we observed that dosage of those gains or losses on those chromosomes is highest in HCC, and some so high that Shauna in the lab describes as insane. So this here is a are figures that illustrates that high dosage 1Q gain here and 8Q gain here is most commonly seen in HCCs. The high dosage ones are these dark red bars. So they're most commonly seen in HCC cases, both in TCGA and in our series, when you compare to other tumors. And the only other tumor that comes close is breast. Now, more pertinent to our discussion of heterogeneity here, we also observed that this dosage is heterogeneous as well, both intratumorally. This here is illustrating an 8Q gain here and two different regions from the same tumor. You'll notice this dosage difference here is represented by these arrows. And there's also intertumoral difference, no surprise. Now, all of these are important because in the lab, we already have data indicating that this kind of dosage situation is tightly linked to patient survival in certain subsets of breast cancers, as demonstrated here. Now, in our HCC cases, as we mentioned, this is still an ongoing effort. The analysis at this point is very preliminary, but already we are seeing patterns that are in the same direction as we see in the breast. So these findings, these features may indeed bear prognostic relevance. This here illustrates another cool observation that further supports the biological relevance of these changes and on these chromosomes. And that is, you see what's happening here? This is chromosome 1 and the 8. These changes, they are already here in the dysplastic nodules. So they may just be early initiating events. And in that way, they are indeed important in tumor development. Okay, next. Obviously what we did next is to see if all this CNA heterogeneity correlated with our histology heterogeneity. And on this front, we were a little disappointed, but not at all surprised that when we did our head-to-head comparisons, no magic correlations jumped out at us. And individual nuclear grades and all these different patterns did not bring out any CNA pattern differences in any significant way. Here's another way of analyzing this data. But we are not surprised. As we mentioned, that this is an ongoing effort. We have reached 200 cases, but we are aware even this number is we are still underpowered, considering all the various variables that we're dealing with. So that's work ongoing. But as is, we already observed that if you consider all the histology heterogeneity as one category, and CNA heterogeneity, including the degrees of chaos, as one category, then there does exist that parallel relationship that histologically more heterogeneous tumors are more likely to be CNA more heterogeneous as well. And this is just an example of this kind of phenomena. CNA very heterogeneous, and they have very different histological patterns in various patterns. And so does link histology heterogeneity to the genomic heterogeneity. This here illustrates another exciting detail that emerged in our analysis, and that is about the heterogeneity of certain potentially targetable focal changes. So we observed that 5 of our cases showed amplification of VEGFA, which is a potentially targetable alteration. I meant VEGFA locus amplification. But in one of the 5 cases, the amplification was only focal. So you see here, this is detection of amplification of this locus, and it's present only in one of the 4 regions that we examined. And some of you may have already noticed these histological pictures here. I don't know if it's because we are trying too hard or what, but it seems that the region that had the amplification seems to show more prominent endothelialization of the sinusoidal cells, more vasculature overall like that. Shauna used the word vascularization. I thought that was a good word. And so obviously, after seeing this, we heard back to the other cases that had more homogeneous VEGFA locus amplification, and we also see the same kind of changes in 3 of the 4 cases, and at least focally. I must point out, this is not something that we captured systematically from the get-go, so I don't know the situation of the rest of the cases and no denominator here. And obviously, more work will be needed before we can say anything about the significance of this morphological feature per se. But I think the more practical message here is that it's about the fact that there does exist intra-tumoral heterogeneity about these potentially targetable alterations. And we did indeed observe this type of phenomenon in at least one other situation. So we had 4 cases that showed amplification of CCND1 locus, another potentially targetable alteration. And here, again, in one of the 4, the amplification was only focally. So you see it's present in region 1, a very high spike, but not in regions 2 and 3. And in region 4, it's only, it has a very low amplitude. These are obviously very low frequency events, but in this era of precision medicine and targeted therapy, low frequency events like this can be quite significant and indeed pertinent too. Overall, we are hopeful that with better tool to analyze our data, especially as we develop systems to capture the global CNA patterns and the degree of chaos, and with more cases, we will be able to decipher the patterns, but the associations better. Lastly, I just wanted to point out that, to our cell biologists in the lab, one of the goals of this kind of analysis is to achieve data that can potentially help develop research models. And so in being involved in this effort, one of the experiences that I found particularly interesting and really inspiring is to sit in on the lab meetings and see how lab scientists get excited at certain observations, and notice that certain deletions or changes of that sort seemed to particularly excite them. Apparently, they have ways, CRISPR editing technology and so on, they can recapitulate that kind of large deletion ex vivo, and then they use some model systems and can then study the different components in those deleted regions, and that way they can sort out tumor suppressors and things of that sort. So really exciting. Anyway, to summarize, this is still an ongoing effort, and the story is still developing, more is still to come. But as is, I think we have provided data that are suggesting that these copy number alterations, both in terms of focal as well as global changes, are significant events in HCC and has the potential to be clinically relevant. And another more important message point from our study is that, these days, as we delve deeper and deeper into the utility of various molecular tools and markers, tumor heterogeneity is something I think we really should keep in mind. With that, I think we have come to the end of this discussion, and we are a debt of gratitude to a lot of people who supported and helped the project. I also particularly wanted to extend a special thank you to Shauna for teaching me so many things and for helping with this presentation. So thank you, Shauna, and thank you all.
Questions?
No questions.
No questions. questions. No, that has to
Unless
be one
Shauna is
question.
in the audience. Shauna, are you here?
I have a question.
Okay.
So I thank you very much for sharing this work. I know, I can say that Jinru was a little uncomfortable with
I'm very
the
uncomfortable.
preliminary nature of the data that we were discussing, but really appreciate you're willing to share what is becoming a very exciting study. So what I was
Thank you.
interested in is the individual cases where you show, increasingly chaotic
Yeah.
copy number changes.
Yeah.
And you said globally that it didn't correlate with grade, but if you take the individual case,
Yeah.
is the more chaotic region recognizable as a higher grade or not?
It's what we are lacking now is statistics.
Ah,
There are clearly portions of cases that have that phenomenon, and then there's not. In order to be definitively say that there's this statistically significant trend, we need numbers. I
Okay.
don't have that at this point.
so come back next
Yeah.
year.
Okay,
and
next
we'll
year.
answer the
We'll talk
question.
about it next year.